Welcome to the Crazy Hat Chemist. So another video here on thermochemistry. So let's get moving. Bam! So today we're doing thermochemistry calculation number 2. Okay, what is the specific heat of copper given the below information? The copper's mass is 43 grams. The heat liberated is 0.480095 kilojoules, with a temperature change from 5.0 degrees Celsius to 34.0 degrees Celsius. All right, so the question is, which equation are we using? Of course, the very famous Q equals mc delta T, but I've changed that delta T into the final temperature minus the initial temperature. So what are we solving for here? So read the question again. It says, what is the specific heat? So let's highlight what the specific heat is in this equation, and that is the CP, the specific heat capacity. So where are all the numbers here going in this equation here? So let's figure them out. Let's look at all the numbers here and let's figure out where they belong in this equation. We're going to be plugging in a Q, an M, a TF, and a TI because we are solving for the specific heat capacity, which is the CP. All right, here we go. This 0.480095 kilojoules is going to be going in for the Q because that's the amount of heat that is liberated. Okay, when it says liberated, that means it's an exothermic reaction. Just another little hint there. Also, the units of specific heat capacity are usually with joules instead of kilojoules. So what we're going to have to do is convert these kilojoules into joules. Hopefully you know that conversion. It's really, really simple. All right, where do the other numbers go? Here is the mass, and that is 43 grams. That is going to go in place of M. Okay, all right. Then we got the final temperature. That is the last temperature. That is the ending temperature, if you will, and that's the 34 degrees Celsius. Then we have the 5 degrees Celsius is the initial temperature. So let's see if we plug these values in, what are we going to get? But first thing that we need to do is convert that kilojoules into joules. So here is that calculation right here. So I've converted the 0.480095 kilojoules into joules using 1 kilojoule is equal to 1,000 joules. And you get 480.095 joules. I've maintained the same number of significant figures that was in that originally, because the number 1 in 1 kilojoule has an infinite number of significant figures. Same with the 1,000 for the joules is an infinite number of significant figures, because both of these are a definition. That is, 1 kilojoule is equal to 1,000 joules. All right, so let's plug in the rest of the numbers into that equation. Now knowing the correct units for the heat term, let's put it right in right there. So I got 480.095 joules, that's on the left-hand side, is equal to 43 grams. And then I got my specific heat capacity, which the correct units for the specific heat capacity is joules per gram degrees Celsius. Then I've got my final temperature at 34.0 and my initial temperature, 5 degrees, and there's a subtraction sign in between the two. All right, so you do know the units for the specific heat capacity because they're right there, joules per gram degrees Celsius. So it might be easier if we got rid of all the units and then put them back in at the ending portion, because you should see that the units here cancel out or actually don't cancel out, as is this case, right? Because we are solving for the specific heat capacity. So what we need to do is rearrange this and solve for CP, the specific heat capacity. So we're going to divide both sides by 43 and divide both sides by the change in temperature. So that's right there. The change in temperature is the 29.0 degrees Celsius. And then we have the 43 grams. So those two numbers are in the denominator. And we have the heat term in the numerator. You should see that right now my units are still correct. That is, joules in the numerator, grams and degrees Celsius are in the denominator. Okay, so I'm going to divide these numbers, and then this is what I get. So this is how I'm going to do this in my calculator, just to make sure you got this. That's 480.095 divided by 43, and then divided by 29. The other way you could do this is 480.095 divided by, open parentheses, 43 times 29, close parentheses, and then equal sign in your calculator. But a really simple method is, if it's in the numerator, multiply. If it's in the denominator, divide. We've covered that before in stoichiometry. So here's the number that we get with the correct units and significant figures. It has two significant figures at the very, very end. Okay, so my number for the specific heat capacity is 0.39 joules per gram degree Celsius. Okay, that is my answer. Oh, I am not done. I actually have one more slide here to show you because I got more information to disseminate to you today. So hang on, don't forget about this. Okay, so you got the specific heat capacity, that's our number. You should be able to plug that back in there, and or you should be able to look at the specific heat capacity for copper. Why don't you Google that or something like that? Look up the specific heat capacity of copper, and it should be pretty similar to this value. Another hint is a reasonable number for a specific heat capacity value for a metal is going to be less than 1. Aluminum specific heat capacity is around 0.9, and gold specific heat capacity is around 0.1. So that kind of gives you the range. It's actually an inverse relationship with their molar mass or density for the specific heat capacity. All right, so I've got one more thing here for you on this next slide. It's going to be a good one for you. All right, you can trust me. I would never try to harm you. Now eat your PB and jelly sandwich, please. I've made it specially for you. Hopefully you know the formula for PB is what element? Of course, that is lead. So now eat your lead and jelly sandwich. I would never try to poison you. No. I am the Crazy Hat Chemist, so of course I got a crazy hat, and I got a great one from one of my students that gave this to me. I love this hat, super cool hat. Okay, if you like anime and stuff like that, you might like this hat. Give me a thumbs up, subscribe to my YouTube channel, and look for me on my website. Google me on my website, that is the Crazy Hat Chemist. There's going to be some t-shirts coming soon. Can't wait for it. All right, I'll see you next time. Bye now.